Hello and welcome to today's class on Understanding Geography with Diagrams. Today we'll be talking about the soil classification. Now for this reference, I've given you over here that the reference book that I have taken is nothing but the Savinder Singh's Biogeography. This is an individual book, and from this I have made the notes and I've made the basic notes of it. Now let's start. See, as per the USDA, that is nothing but the United States Department of Agricultural System, has divided the world soil into three broad categories: the zonal, the azonal, and intrazonal. Now, from this itself, you can guess the meaning of that. The zonal is nothing but they belong to a particular zone, maybe polar, maybe equatorial, maybe temperate, etc. Azonal means that they do not belong to any particular zone, and you can find it everywhere. Almost everywhere you can find this kind of a soil, be it the polar region, be it the equatorial region, or any region. Intrazonal is nothing but that is found in between the zones or within the zones. Let's start. First of all is your zonal soil. The zonal soil represents the fully matured soil which have developed under the condition of good soil drainage. This is the first definition of your zonal soils. The zonal soils are characterized by the full development of almost all the soil horizon. I have written it almost all, means not necessarily all the soil horizons are developed, but almost all soil horizons are developed, comma, their number and characteristics may vary according to the local condition and degree of the human interference. Yes, this is an important thing, that the number and the characteristics of the of the zonal soil varies as per the condition. When I say local condition, means nothing but your climate and as per the human interference. Now the human interference with in modifying the soil characteristics is something that we see in the present times or in the present era. Now let's begin with the classification of the zonal soil. The zonal soil, I have classified it into pedcol, pedalfer, and the tundra soil. The pedcol again has been classified into xerism, chernozem, and the chestnut soil. Pedalfer into the long grass and forest and their individual classification. Last but not least, tundra. Now most of you would be having the biggest doubt is that, sir, how to remember the name? See, first of all, you do not have to remember anything. Simply understand. Remember that, like I remember that it was the Piyush sir, he used to teach in the IAS core. He said that कि चीज़ों को समझ जाओ ताकि याद रखना ना पड़े, रट्टा ना मारना पड़े, सिर्फ चीज़ों को समझ जाओ. So that is what we will be attempting over here with the zonal classification of the soil. Let's move on. First is your pedcol soil. Now understand this pedcol soil. Now pedcol soil is nothing but the soil which is rich in calcium. Pedcol. Let's see, call for calcium, and that is pedcol soil is nothing but the soil rich in calcium and representing the process of calcification. What is calcification? Is nothing but when the soils are rich in calcium. Now this type of the soil are associated with the arid and the semi-arid type of the climate. Now in this arid and semi-arid type of the climate, what happens is that within the soil layer there is capillary action, as a result of which the calcium that lies within the soil bed comes to above over here on the top soil. Hence the soil becomes rich in calcium. And remember one thing, that the calcium is nothing but a macronutrient that is highly essential for the plant growth. Hence within this pedcol category we have the xerism, chernozem, and last but not least is your chestnut soil. Let us understand the xerism and chernozem. Now the xerism soil is nothing but the arid climate soil with coarse texture. Arid climate soil, I would call xerism, is also called as your desert soil. You can write this if you are making the notes. Now next point, also the extreme form of the chestnut soil, in which lime and gypsum come nearer to the surface because of the upward capillary action, which I have already explained. Now with respect to, if you do not know what capillary action is, I would first of all suggest you to watch my video on the soil and then watch this video. Next, it is also characterized by your lack of humus. Next, however, when irrigated, xerozems can be very fertile because of the high base status. What is this base status? Means they have a whole lot of nutrients, that is minerals, that is deposited within the soil. Though they lack in humus, but there are nutrients, and that if we irrigate them properly, and that if we even use fertilizer properly, then we can also have productivity in the xerosum soil. Now I can give you the example of the xerosum soil. The xerosum soil is found in India, where it's none other than your Thar desert region. Yes, this is the region. This is the region where we find the xerosum soil. This is the part of Rajasthan and this is the part of Gujarat. In this part we find the xerosum soil, and in over here in the xerosum soil, what happens is that nowadays the NDDB, I hope you know what is the NDDB, the National Dairy Development Board, is using this xerosum soil or the desert soil for the fodder crop. What is this fodder crop? Fodder crop is nothing but that particular kind of a crop which is used to feed your cattle. NDDB is using this fodder crop growth in your xerosum soil, where in your Thar deserts. And the very reason also for the growth of this fodder in the xerosum soil is that to minimize the soil erosion via wind. Next, we have the Chernozem. The Chernozem, I also call it as the black earth soil. Now, Chernozem is nothing but the soil of the semi-arid climate belonging to the steppe biome. Now, if you do not know where it is the steppe biome, I would again suggest you to watch my video on the climatic classification of the Köppen. Next, Chernozem is characterized by calcification again due to the capillary action. Again, this soil is also correlated to the development of the A1 horizon. A1 horizon is nothing but your dark colored horizon, or the true soil we call it, and it is also rich in your humus. Now with respect to the Chernozem, it also says that it also corresponds to the bread basket of the world and is used for the commercial wheat farming. The see let us first of all let us look at the location where the Chernozem is located. Now this is mostly, I'm drawing the figure of your North America, and this is the location of your Chernozem soils. This Chernozem soils are also called as your steppe soil, and this region, that is your Canada and the wheat and the Canada and the USA, this entire region is used for the growth of your wheat or the commercial wheat farming. Hence it is called as hence it is used for the commercial wheat farming. Again, the loess in this loess is the ideal parent material for the soil. Now what is this loess? Loess is nothing but that soil which has been formed because of the deposition by your wind. So basically, can we differentiate between this xerosem and Chernozem? See, xerosem is found in the arid climate, but Chernozem is found in your semi-arid climate. Number one. Number two, in xerosem, apart from calcification, there is also deposition of your lime. There is also deposition of your saline materials. As a result, the salinity in the xerosem soil remains high when compared to the Chernozem. Now let's talk about the fertility. Chernozem is more fertile than xerosem. Now let us talk about the economic usage. Again, Chernozem has a greater economic usage than your xerosem. How? The Chernozem has been used for the commercial cultivation of the wheat, whereas the application of the xerosem in plant cultivation or in the crop cultivation has been limited. Now with this, what you can do is that you can solve the UPSC 2017 question of the mains question, which said that what is the difference of the Chernozem versus your xerosem. This is one of the important question with respect to UPSC. Next is your chestnut soil. Again, this chestnut soil comes under your bed call category. Like we said, the chestnut soil occurs on the arid side of the Chernozem belt, under the natural vegetation of the low grass steppe. The alluvial carbonate layer is closer to the surface than in the chernozem, and they have a lower organic content. See, so how does we differentiate it from the chernozem? See, within this chernozem, what happens is that let me again draw the diagram of your this North America. See, I had basically said that this was your chernozem area. Now over here there is the arid regions. In this arid region, we basically find your chestnut soils. So first of all, the chernozem, sorry, this chestnut soil is nothing but the kind of the pedcol soil which is found in the arid side of the steppe type of the soil. The steppe is nothing but your low grass soil or the steppe soil, or it's basically the steppe soil name has been derived it from the steppe grasses, which are nothing but the low grasses. Now one thing that you may be asking, sir, what is the difference between steppe and a prairie? Steppe are the short grasses, prairie are the long grasses. In the steppe type of the climate, the amount of rainfall ranges from 25 to 50 centimeter of rainfall. Where there is a prairie, the rainfall ranges from 50 to 75 centimeter. Again, I would suggest please watch the Copen's video to have a basic clarity if you do not understand this. Next, we have your pedalfer soil. The pedalfer includes your long grass soil and the forest soil respectively. Now within this we have come over here is the long grass soil. Now the long grass soil is nothing but basically a transition between the true pedcol and the true pedalfer. See, pedcol soil, within this pedcol soil we have this long grass soil, and this long grass soil, as we had drawn over here in the diagram, you can see is that this is your pedcol, and then we have the pedalfer, and the pedalfer, one of the varieties, long grass. And this long grass is nothing but the transition between the pedcol and the pedalfer. Means they have the similar properties like pedcol, and somewhat they have the properties like pedalfer. Hence we call it as the transition zone between the true pedcol and the true pedalfer. Now the prairie soil. The prairie soil again belongs to the subhumid climate with taller grasses, as I have explained, than that of the steppes, with lesser degree of calcification, making them less fertile than the steppes. I hope you got this point, that in the prairie soil the level of calcification is very low. Next, we have the red soil. The red soil is also called the grumosol. Sorry, it's your red yellow soil. That the red yellow soil is nothing but the soil of the savanna, or it's called the savanna type of the soil. As we have already read in the Copen's classification, that the savanna type of the soil is classified as AW. AW means that they receive a winter rainfall, whereas the summers are dry. Next, they receive the summer rainfall, whereas the winters are dry. Please forgive me for that mistake. Next, we have the red yellow soil. What is this red yellow soil? Again, it's the soil of savanna, or the savanna type of the soil. Now within the savanna type of the soil, one of the important characteristics is that the humus, though is it present, but the layer is very thin. Next, the soil is characterized by the minimal leaching. Leaching, again I have explained in the video, again I have explained in the soil video, please watch that. And lateralization, that is both leaching and lateralization are minimum. Despite of it, there is absence of the alluvial and the alluvial horizon. Again, alluvial and alluvial horizon has been explained in the soil video. Again, I say you that if you are watching this video without watching the soil video, then it would be completely worthless, because you won't be able to understand the basic terminology. So I would request you, please go on and master the video on soil. Last but not least, the important characteristics of the red yellow soil is that this is also characterized by the dry season cracking, just like your black soil. So what are the characteristics of the red yellow soil? First of all, this soil has a thin layer of the humus. Again, within the soil, the leaching and the lateralization is minimal. Last but not least, this soil is characterized by the dry season cracking. Again, within the savanna type in the savanna type, we have the very long grass, or the savanna grass that we say, which are less in the nutrient contents. Next, we have the forest soil. The forest soil, also called as the true pedalfer soil, which is rich in aluminium and iron. You will know why they are rich in aluminium and iron as we study more. First of all is your laterite soil. We already have some idea of the laterite soil in the NCERT itself. In the laterite soil, there is abundance of sickly oxides. The sickly oxides is nothing but your iron and your aluminium, which accounts for the red-brown soil and the yellow color due to the leaching and laterization. Again, we have the A horizon over here is acidic and low in humus content. We have the B horizon, which is clay. Now you would say, sir, why the humus content is low and why is it acidic? See, laterite soil basically occurs in your tropical regions, such as in India. The example is your Western Ghats. Now in this region, what happens is that the bacterial decomposition rate is very high. As a result of this, the soil, the humus within the soil is easily decomposed. Next, in general, they are less fertile and acidic as humus in the soil is completely decomposed by the bacteria. Next, they are common in your equatorial rainforest. Easy. I hope you got the laterite soil. Again, the laterite soil is also called as the feral soil. Feral means iron, Al means aluminum, soil means. I hope you got the why it is called as the feral soils. Next, you have the podzol soil. The podzol soil is produced when the topsoil is rich in silica. They are of the following types. We have the humus based podzol and the iron podzol. Humus based podzol is wherein the B horizon is rich in humus, and iron based podzol where the B horizon is rich in iron. I hope you remember that the B horizon is called as the zone of the elevation, and that is the transport of your material from the A to B. Next, we have the clay podzol. What is this clay podzol? The clay podzol is nothing but it is developed by the iron pan in the B horizon. Such soil is found in the taiga forest biome. And as if you have watched the soil video, then you obviously would have known that cheluvation is a process that is basically responsible for the formation of your podzol type of the soil. Now after podzol, we have a podzolic soil. Now this podzolic soil, we find it in two regions. One is your temperate hardwood deciduous, such as the Manchuria. We have the temperate hardwood deciduous type of the forest, and we have the tropical hardwood deciduous type of the forest. Where do we find this? India. Simple. In the temperate hardwood deciduous forest, more fertile. Why? Due to the supply of leaf litter with the absence of excessive leaching, laterization. This is number one. And also remember that in the temperate region, the temperature is quite moderate. Hence, the rate of decomposition is also slow. Hence, they are rich in humus. Whereas in the tropical hardwood deciduous, it is less fertile due to the excessive leaching and laterization, and also because the bacterial activity in the tropical region remains high. And this is also something you can add it to your notes. Next we have is your brown forest soil. So the brown forest soil are found in the milder climate of the podzol zones, supporting the deciduous forest cover. Leaching in this soil are less intense than the podzol soil. It's simple. Next, there is absence of the calcium in the upper profile and also the downward movement of the sickly oxides. Above all, well distributed humus makes them less acidic than the podzol. So basically what we got from the brown forest soil is that these are less acidic than your podzol, number one, because the humus is well distributed, number one. There is absence of calcium in the upper profile and also the downward movement of the sickly oxide. Again, what is sickly oxide? None other than your Fe and Al. Next, these soils are widespread in your Britain except in your highlands. Next, the tundra soil. The tundra soil is highly variable and stable. Sorry, I have written it in, but this is highly variable and stable. In the stable slope condition, there is presence of peaty layer of the soil due to the slow rate of plant decomposition. What is the peaty rate of the soil? Means basically peaty type of the soil develops where the soil is inundated by water. In the tundra region, there is the melting of the water, and this ablated water actually results in the development of this peaty type of the soil. Hence, in the stable slope condition, there is presence of the peaty layer of the soil due to the slow rate of the plant decomposition. Number one. Number two, the soil here is thin in areas of active slope movement. What is this active slope movement? Let us say that this is your tundra region, and here we have your sloping, and wherever there is a movement of the active slope, that is nothing but your glacier type of the movement, over there the soil is obviously thin. This is easy to understand. Next, soil is ahumic, means it is not rich in humus. Full stop. Where there is no plant growth, brown polar desert soils are of this nature. Next, in exceptional cases, thick dark organic A horizon is found in the bridge forested of the Tundra region. This is an exceptional condition, that it is in thick dark organic A horizon is found in the bridge forested of the Tundra region. The Tundra region, there are particular regions but there is a bridge. Bridge is nothing but a type of the plant that grows over there. And wherever there is the dominance of such bridge vegetation, what happens is that there we find exceptional development of a thick dark organic A horizon. Simple. Next we have your intrazonal soil. Now within this intrazonal soil, I have missed an A over here. The soil category regulated by a specific structure of the process in a given condition. Yes, means that the soil that is developed over here is dominated by a specific process. This includes both the fertile and the infertile category. First, let us talk about this infertile category. The infertile category, we have the halomorphic, hydromorphic and peat bog soil. Within this halomorphic, as you can, halo means nothing but your salt. Hence, this is a saline soil. Hydromorphic is nothing but your water. And peat bog is nothing but your marshy. This is an extensive form of your hydromorphic is nothing but your means the extension of a hydromorphic soil is nothing but your peat bog soil. Do not need to write this, but just understand this. Halomorphic soil is excessive magnitude of calcification resulting in the development of the saline alkaline infertile soil. Means it's because of the excessive calcification this kind of soil develops. Next, we have the types. One is the solanchak or the white alkali soil. Another we have the solonets or the black alkali soil. The white alkali soil develops in the depression and exhibits white salt crust in dry period. And let me tell you about this, that it's basically we find this in Egypt, and this is also used for the manufacture of the salts. Again we have the solozets. It's nothing but the black alkali. It is formed due to the intense alkalinization, same process, and there is the presence of high rate of sodium carbonate, that is Na2CO3. Again we have the solodic soil. It is formed when the leaching in presence of excessive sodium causes loss of clay and sickly oxide, forming the bleached elevated horizon. So basically in the solodic soil what we came to know is that the rate of alkalinity is high, but there is absence of clay and there is absence of sickly oxides, that is aluminum and iron, due to your leaching. Next example is your Etosha pan in Namibia and the Kutch or the run of Kutch. Next we have is your hydromorphic. These are the soil types that have undergone claying due to the water logging. They are associated with the marshes, swamps and poorly drained land. Easy to understand. Next, there are of two types. One is the groundwater clay and we have the surface water clay. That is the type of the hydromorphic soil. Again, where do we find this? We find this over here in the lower course of the river Mackenzie. Where is river Mackenzie? Canada, and in the Ob and Lena in Russia. Next we have the peat bog soil. The peat bog soil also is the soil that have undergone claying, generating mineralized infertile soil or the O or the O horizon, which is characterized as excessive decay. I hope in the plant horizon you remember that first horizon is double O, next horizon is O, next we have the A1, A2, A3 and next. Again I would suggest you to go back to my video to watch the soil if you do not have the idea of this. Next, where do we find this peat bog soil? Pantanal Basin, Brazil, Gran Chaco, Argentina, Pipet Marshes, Belarus and in Ukraine. Next, we have the fertile. The fertile category is also called as the Galamorphic. The fertile category has been divided into two groups, that is your Regur and your Regina. This Regur is nothing but your black soil. Simply it has the properties, simply the black, what are the properties of the black soil is similar to the properties of your Regur soil. It is the black colored soil developed over the tableland. Easy. Diverse mineral but lacks humus. Next, more than two-thirds of the Regur soil is devoted to your cotton cultivation. Last but not least, where do we find it? We find it in your Ethiopian highland and none other than your Deccan Trap. I hope you remember that these are the regions of your black soil. Maharashtra, Kathiawar Peninsula and Gujarat are very rich in the black soil. Next we have your red gina. The red gina is developed over the uh, limestone structure. This is the limestone structure and over it we have the red gina. Hence in the red gina what we have is that it's rich in calcium. One more thing about the red gina is that they lack diverse mineral but are rich in humus. But look at the Regur. Regur says that there is diverse mineral but lack in humus. The opposite is in the case of red gina. Next, where do we find it? In the terraces in the Anatolia Plateau, Turkey, number 1. Sarawak and the Sabah provinces, Sarawak, Sarawak, Sarawak and the Sabah provinces in your Malaysia. Next, we move on to the ozonal category. In this ozonal category, they are present widely as I had already mentioned. Within this category, we have the montane soil and we have the gradational soil. What is this montane soil? This montane soil, I call it as the forested soil or I call it as the scree soil. So please do not get confused with the names. Now the montane soil is well drained. Why it is well drained? Now just look at it. This is the mountain. A mountain has a slope and any soil which is located in the slope would obviously be well drained. It is that easy. It is again humus rich and fertile soil. Again the limited depth. Obviously why the depth of the soil is limited? Because the soil is located upon the slopes. Hence this soil has a limited depth. So basically from the mountain soil or from the name itself we got two things. First of all, the soil is well drained and the limited depth of the soil. See, just from the name itself we can guess out what would be the characteristics of the soil. Other factors that affect the mountain soil is your sign of latitude, number 1, the height or the altitude, last but not the least is your sun bearing slope. See, sign of latitude, basically what happens is that the mountain soil which are located in the tropical region to the mountain soil which are located in the this temperate region, the mountain soil in the tropical region basically would be more fertile than that of the temperate region. Similarly, look at the height. Now the mountain soil, again sir, where the slope gradient is low, the soil thickness would be minimum and it would be well drained. At least the soil would be stable over here. But consider that in case of the Everest. Now in the Everest the slope is very steep and in this case you cannot expect a soil to be stable in this region. Soil might be found but they won't be very stable. Now let's move on to the gradational soil. The gradational soils again we have classified into glacial till, loess and alluvial soil. See, the gradational within this ozonal soil category, the ozonal soil are majorly represented by the gradational soil. So basically ozonal category we talked about the montane soil and the gradational soil, and within that the gradational soil is the majorly distributed across the world. Why? We'll see about it. First is your glacial soil. The glacial soil is formed in the outwash plain of the continental glacier. Simple. It is also called the fluvio-glacial deposits. It's characterized by fine texture and mineral-rich soil. This is the example that I have given. This is your outwash plain. What is this outwash plain? Outwash plain is nothing but it's as the name suggests, it's a plain area. It's a plain area where the level of the gradient is low. Hence, we find the considerable deposits of the soil. It simply means that the slope is very less, hence soils are being deposited. Again, what are the kind of soil that are being deposited? We call it as the till or the glacial till. Now the tills are divided as per the location. The till which are located at the corner, we call it as the lateral till. These two are the example of a lateral till. Then we have the medial till. As the name suggests, this particular till is located in the middle of the plane. Last but not least, terminal till. Again, as the name suggests, this is located at the end. Very simple. No need to remember anything, just understand, just through the diagram itself we can write it. Next, then what is the problem of this kind of the soil? This kind of soil lacks humus added to the waterlogged condition that makes it less fertile. This soil is fertile but it is less fertile because lack of humus and the waterlogged condition. Next, what we have is the loess. I have already talked about loess. Loess we had talked during while we were discussing your Chernozem or the black soil. Excuse me for a minute. Next, we have the loess. Loess is nothing but your wind deposited soil, which requires thousands of years. Why? Because the rate at which the wind deposits is very, very slow. Again, thousands of years of continuous deposition to develop the recognizable deposits. What is this recognizable deposits? Means the deposition is so slow that even for a 1 centimeter of the soil to see that that a particular centimeter of the soil has developed, it takes a whole lot of time. Next, what is the problem of the soil? First of all, in general, they lack humus. Why? See, wind have deposited the soil, and where does the humus comes? First of all, there would be a plant that will grow on the soil. The plant will put down the leaf litter, and that leaf litter will be decomposed, and then we will have the humus. So in general, in the very beginning, they lack humus in general. However, there is exception being the lowest hill in the Iowa, where is Iowa, USA, that has organic rich humus due to the grassland biome. So basically in the Iowa in the US, what happens is that this lowest has been dominated by the grasslands, and this grasslands dead, and that is the death of this grasses and decomposition by the microorganisms has led to the development of the humus. Lowest again is of two types, glacial and desert. Why do we call it glacial and why do we call it deserts? Based upon the source. Means that if the wind is deriving the soil from the glacier and depositing in somewhere else, then I would call it as a glacial loess. If the wind has been derived from the desert, I would call it as the desert loess, as the name suggests. Next, example of the loess is nothing but your northwest Huanghe basin of China, northern European loess belt stretching from South England to the North France, Germany, Poland. Next, we have the alluvial soil. Now, the alluvial soil, as you know, as you have already read, that it is basically a depositional type of the soil which has been deposited by the river, by the gradational action of the river. Now, within this alluvial soil, please look into this, that it is developed by the universal agent of gradation, that is your running water. However, there is variation in texture, process of formation, and the parent rock. Now, texture. Alluvial soil texture is seen in the long profile of the river. This is the long profile of the river. What do we understand by this long profile of the river? It is nothing but the location of the river from source to mouth. Basically, I would give you an example. Let us take this. This is your Ganga river. We have the Alakananda and the Bhagirathi that combine to form the Ganga river. Now this, and then Ganga river gets deposited in where? In your Bay of Bengal. Let me draw the diagram again. This is your Alakananda Bhagirathi. So if I say what is the long profile of the river? Long profile is nothing but the entire river from the source to your mouth. Simple. Next, what we find in the long profile of the river is that first of all, what within the side of the river, this is your flood plains. So basically the flood plains are dominated by the coarst grain. What is coarst grain means? In Hindi I would call it mota dana. Means the soil that has been formed is quite thick, and in the bottom, or I would say in the delta, the soil is fine grained at the delta. Now you can ask me, sir, why it is coarse grained over here and why it is fine grained at the delta? See, the river, that basically what happens, that all this materials that has been derived by the river is basically settled over here, but they rarely go attrition. But as the materials which flow over a long distance, they go attrition. Attrition means they clash within each other. As a result, smaller particles are developed, and hence the deltas have a finer gradient. Next, the soil at the delta is more fertile than that in the floodplain. Why? First of all, they are fine gradient. Next, another thing is that the prevailing climatic condition. See, the pedalfer alluvial of the Amazons are less fertile. Why? Because of the leaching. Basically, if you know that in the Amazon is basically belonging to the equatorial rainforest or to the AF type of the climate where there is 300 centimeter of the rainfall well distributed throughout the year. So obviously where there is more rainfall, there would be what? Leaching. Hence the Amazon soil, which is basically developed by your Amazon river, that is the river on the, that is the soil on the floodplains, soil on the delta, they are less fertile because they undergo heavy leaching. Simple. Again, it says that it is less fertile than the pedicol alluvial of the Nile. Now, where is Nile located? Obviously, we know that Nile is located in your Africa, and Nile basically starts from Ethiopia and drains over here. Now, basically, what happens that the Nile, there is the climate is arid type of the climate. Within this arid type of the climate, again we have studied that there is calcification because of your capillary action. Hence, the pedicol type of the alluvial in the Nile is more fertile. Now let's talk about the parent rock. It says that the red alluvial of the Amazons derived from the Brazilian highland are less fertile than the black alluvial derived from the Kordofan plateau of the river Nile. Again, we are comparing alluvial and the river Nile. Now the alluvial soil, it basically passes through what? It basically, the Amazon river. First of all, let's consider the Amazon river. Amazon river passes through the Amazon rainforest, and the Amazon rainforest is located over your Brazilian highlands, which is nothing but that is the high deposition of your red soil. Hence, this red alluvial is less fertile. But when the Nile is moving, the Nile moves over what? The Kordofan plateau, or or to say that this Kordofan plateau is nothing but your parent material. And this Kordofan plateau, as the name suggests, is basically a lava plateau. Hence, from the lava plateau, what happens? We know that the lava plateaus are rich in minerals. Hence, the alluvial soil which has been developed by the Nile moving over the Kordofan plateau is more fertile than the soil which has been developed by the river Amazon. Simple. Next, we have the comprehensive soil classification system. Again, this comprehensive soil classification system was established in 1975 by the US Department of Science, USDA. I'm extremely sorry, I just got tired, that's why I mispronounced it. Now, again, the soil I would classify into three categories. This is the well-derived horizon, weak horizon, and the excessive decay. Please understand this very carefully. We have over here forest soil. First, we have the oxazole. This oxazole is nothing but your laterite soil. Again, we have the alphazole. Alphazole is nothing but your podzolic soil. Again, we have the spodzole. Spodzole is nothing but your taiga type of the soil. In the grassland, we have the ultisol, that is the red yellow soil. We have the mollisol, that is the chernozem. Again, within this head, we have the others, that is your aridizole. Aridizole is nothing but your cerosem. We have the vertisol, it is nothing but your regur. We have the antisol, which is nothing but your volcanic ash soil. We have the glaisol, that is nothing but your tundra or the permafrost soil. We have the weak horizon. Within this weak horizon, we have the antisol, it is nothing but your gradational soil. Inceptisol, it is nothing but your brown forest soil. Next, we have the excessive decay. It's nothing but your histosol or the peat bog soil. Simple. I hope you got a clarity of this, and basically you do not need to write this. This is just for your understanding, just to avoid confusion. Sometimes basically what happens is that the examiner directly picks up terminologies from here, especially in your prelims and in your mains. So basically, in case the question is coming on this basis, I would request you not to get confused and just have a conceptual clarity of this. With this, you can obviously get through it. Supposing the examiner asks characteristics between the or the difference between the alphysol and the oxazole. So obviously you know that oxazole is laterite soil and alphysol is podzolic soil. You have to do nothing but write the difference between the podzolic and the laterite soil. Done. It's that easy. Again, in case of the prelims, also we have a trouble when they basically start using this terminologies, and then we basically have a perception that we do not understand this terminologies. Hence, in this context, I would again say is that ki, use this term, just understand this terminologies, understand the soil, understand this terminologies. This will just simplify your mains and your prelims. Basically, for the Odisha Public Service Commission, I would say that ki, I would say that complete till this, and this would fetch you a proper 60 marks. Not a proper 60 marks, basically it will help you to get a marks which would be above 45, and I guarantee that. Thank you, that will be all.